Y'all know what it is. Fat Finger Squad in the building. Today's lab is configuring port. What is it? Configuring interface-based port address translation. We got my man S Smooth in the building. What's up, S Smooth? You've been early to class lately, man. You've been leaving the apple on my desk. Like the teacher's pet, man. I'm just playing with you, man. We're gonna wait for some stragglers to get into class real quick. Today's lab is going to be from page number 293 if you got the book. 293. And we're going to be doing this together because I did not really do like a practice run. I mean, I sort of kind of tried, sort of kind of. Notice how I did that, right? And just kind of got stuck. And I just was like, you know what? Let me just try to fumble through this while I do the live stream, man. It's all good though. So I'm not going to be really teaching y'all this. This is more of a reviewer for me. And I guess it might be a review for some of you guys if you've done this before. But you know, port actually just natting in general was kind of a weakness of mine. You know, nat was kind of confusing for me. ACLs were definitely confusing for me. I mean, I know the concept of it and you know how it works and stuff like that, but just to remember the commands and the directions and stuff like that, the ACLs can be confusing, and so can nat in a way. So I'm gonna kind of be kind of fumbling through this as we do this, but I'm gonna try to race through the easy part, you know, like configure the IP addresses, host name, stuff like that, and you know, basic connectivity, and then we'll get right through it. So we got Joseph B in the building. What's going on, Joseph? Haven't seen you in a minute. Need to see what this is. The title caught my attention. Yeah, interface-based port address translation. So basically, it's natting. I'm pretty sure you know what natting is. Network address translation, where we translate a public private IP address to a public IP address, right? Because private IP addresses are not routable on the internet, right? So we got to do some kind of conversion or translation so that way we could use a public IP address while we're, you know, kind of like let me draw it real quick. So I know we've got some private. This is a private. Let me get a different marker here. This is the 10 address space. That's all private IP addresses. But just for the sake of this, we're going to make pretend that this right here is the public internet. And this is the private, like, local area network, right? So when we are talking outside, yes, our address is 10224. But once we get out here, we're going to translate it into something else. I don't know how to, you know, kind of show translation here, but we're going to translate our address into something else so that way we can use a public IP address. The problem is, you know, we ran out of IP address spacing for one, and two, that's the reason why we've been able to continue using IPv4 as opposed to IPv6 because of things like NAT. So doing this, especially with port address translation, we were able to reserve our IP addressing space by adding a port number to IP addresses. So let's see here. It said work is killing me, man. That's what's up, man. Work is killing me too. Well, that's not what's up, but I ain't gonna say it's killing me, but I do have a lot of work. In a way, it's kind of a blessing because there's a lot of people that's unemployed, and you know, right now the unemployment is pretty high right now. So so this is just a class on NAT, IP NAT source. Yeah, pretty much. I wouldn't say a class because it's more of my learning journey. You know, this is a review for me. I was studying for the CCNP exam. I don't know if you remember from my old videos from back in the day and stuff like that. I'm just kind of going back, reviewing stuff from the CCNA exam. Filling a lot of gaps in my knowledge and stuff like that. We typically use this book right here. This is where we lab from, 101 Labs. Cisco CCNA version 4. You can get a copy of this from 101labs.net. There's also a link in the description box below. I love this book because they say experts agree that we retain only 10% of what we read, right? From the official cert guide and all these other books, Network Warrior and stuff like that. But 90% of what we do. So we retain 90% of what we do. So hands-on, kinetic learners and stuff like that. It's just like driving a car, right? You can read all the theory all you want, but you're not gonna really learn how to drive a car until you're actually behind the wheel. And that's why I love this book, because it actually gets us behind the wheel and start driving and stuff like that, right? So, okay, I see what you mean. You're doing PAT. Yes, correct. Port address translation. Let's see here. I know NAT, but a NAT port? Yes, a NAT port. So basically, well, this is port address. But let me see. Do they add a port number into this one? Because I didn't really, like I said, I did not really go through this lab. So I'm gonna kind of fumble it, but it says port address Translation. Basically, you take an address and then you're gonna add a port number to it, right? So for example, this IP address, you're gonna add a port number. Let's say the port number is 80, which is a well-known port, right? That's your pop quiz for today. What's the port number 80, right? And when we take an IP address and put it in conjunction with a port number, right? That is called a socket, right? So we use a socket to basically talk out of the internet when we're doing this, right? And that because we could have another host, right, using, let's say he uses this as his public IP address when he gets out, right, but he's going to be using another port number to make him unique. So let's say his port number is, I don't know, 950 or something like that, right? And that's how he's going to have it. So he's going to have this IP address, but he's going to use the port number 950 when he's talking out. So, and I don't remember how to really do that, so I'm going to kind of go through it while I'm going through this lab and stuff like that. Hopefully you got this book, and if not, go ahead and click that link down below, get you a copy of this book. We're going to start with router 1. Give it a couple minutes for some late stragglers to come in. He said, it should be a random number, I think. Yes, I believe that's called, yes, HTTP is port 80. Damn, you on fire today, Joseph. Port 80 is HTTP. And yes, it should be a random port number. That's called, I believe, the ephemeral port number. So it just gives you a random port number and stuff like that. But I don't think that's what this lab does. We'll find out what it does. Because, like I said, I did not do a practice run or anything like that. What else we got on the agenda? I usually start at about 10 minutes after the stream starts and stuff like that. Shout out to my man Osiris. I believe that's his that was his handle. Anyways, he let us know in the Discord server. If you guys are not sure, Joseph, if you don't know, that is our Discord server. So after class and stuff like that, we kind of discuss some other things, or maybe some things that are off topic, or any other topics people want to see. They kind of hit me up on the Discord server and let me know. So go ahead and join there. But we've got my man Osiris, who just passed the CCNA exam. So not only do you get the certificate, but you get these bruhs here. And yeah, shout out to him. He said that what he said. So yeah, he said he passed the CCNA today, for one. And damn, I took off my damn my kudos there. So and he said, thanks NetworkBruh for the wireless help. You helped me pass for sure, man. And I appreciate that. I love it when people hit me up, send me DMs on Instagram and Twitter and stuff like that. Let me know that they passed the exam because of my videos. And I doubt people are just saying that just to tell me this, but I'm glad that my videos help. And y'all know I just kind of explain things differently, and I'm glad that people at least acknowledge that my videos help and stuff like that. So appreciate that, and shout out to Osiris for passing the CCNA exam. What else we got here? LeBron James is under fire for saying that they need to prosecute that one dude that shot the little girl and stuff like that. Man, that's crazy, man. They just going off, man. I don't know what's going on in this world, man. Anyways, let's keep it positive here. Let's see. Yeah, what's up, man? So yeah, Osiris 25, man. Appreciate you for letting me know that you passed the exam, and congrats on that. What else? That's pretty much it, man. So let's go ahead and get started. Task number 1 was to, I believe, just do the host names and stuff like that, right? Yeah, configure the host names, which I'm pretty sure y'all know how to do, and I'm pretty sure Joseph knows how to do, since he knows the port number for HTTP, right? So, and y'all know I'm using hardware. If you're using EVN-G or GNS3 or anything like that, go ahead and fire that up. I don't know if Packet Tracer supports this feature or not. I realized there was a lot of features that's been missing, and a lot of stuff that I did not realize, like NVI0 when you're doing port address translation or natting. I don't remember seeing that interface being created when you do natting in Packet Tracer. So those little things like that, kind of hindered me while I'm using Packet Tracer. So, and now I'm using live hardware. So anyways, y'all know the configured host names. If not, just follow along. I already got them saved as the host name. So he's router 1. Go ahead and drag and drop one router, name him router 1. A second router, name him router 3 for some reason, and a third device, and call him switch 1 or SW1, right? And that's pretty much it for task 1, right? Task 2, we got 8 tasks today. I'm gonna try to race through the easy part, man, because I said we're gonna try to do the labeling and cabling as fast as I can. We're gonna go to router 1, and we're gonna do these interfaces and clocking. So we gotta do clocking, do that IP address for that interface, that IP address for that interface, that IP address for that interface. We're gonna put that interface VLAN, and then for this, we're gonna put that in VLAN number 50. So y'all go ahead and do that. If y'all don't know how to do it, just go ahead and follow along, right? So We're going to go to global config mode and interface serial. My interfaces are different. Mine says serial 000 instead of serial 00. So your interfaces might be different. Just pay attention, right, to what your interfaces are. But the concept is the same. This is actually the same topology as the last two streams that we did, right? 254.1 subnet mask of /29, which is what's that? Not 240 but 248, right? We no shut that bad boy because they are out the box shut down. We get to put the clock rate, right? Because DCE, the clock rate, they said for task 2 to provide a clock rate of 256 kilobits per second to router 2. So router 1 gotta do some clocking to router 2, or in my case router 3, because I think this was from the old book and stuff like that. So he said 256 kilobits per second, right? We already know shut that bad boy. Dave W checking in. He said, yeah, maybe I should stick around because I didn't know we can manually put port numbers. I don't think that you can manually do it, but we're about to find out, because we're about to find out. Like I said, I did not really go through this lab. Typically, I do a practice run and stuff before I live stream, but I was busy at work, and when I got home, I did not really have time. Kelvin said more NVIs. Yes, man, actually less. That feature did not work very well. And as you can tell, as Kelvin said, that feature does not work very well. And when we got stuck last week, wondered why the Nat Translation did not work. Well, the NVI 0 interface did not work really well. So Joseph B, statically setting port numbers would be static PAT, which is not the same as dynamic PAT overload. That's for things like port forwarding and such. Yes, correct. This is interface-based port address translation. So I don't know if you want to give your explanation to that, but like I said, this is going to be a review from me. So natting and padding was not really a strong suit of mine. So we no shut him. We gave him the IP address. We put this clock rate command. Let's show our work. Do show IP interface serial 000, and it is /29.1. So we're good to go there. Right now he's down because this one right here is down. So once we bring this interface up, that other side should come down. So we'll go ahead to router 3, set that interface 000. His IP address is 192.168.254.2 /29, which is 248, right? No shut that bad boy. What else they wanted us to do? We did the clocking, the IP addressing in router 1 and router 3. Task 3 was to configure Vlan 50 and name it same thing as last lab, right? Go to switch 1. Go to, they said create a Vlan 50. Name it Nat_VLAN, all caps. So Nat_VLAN, all caps, just like that. And then assign FA02 to that VLAN. So this interface, they want us to put it in that VLAN, just like I said earlier. So we get out of this, and let's show our work too. Remember, we always show our work. I don't care how simple it is. Show interface brief, or VLAN brief rather. Nat VLAN. We're gonna put this interface in that VLAN, right? So go to global config mode, interface blah blah blah, interface. Y'all see how I did that real quick? Control A. Try to know your little commit, the little shortcuts there, right? Switchport access VLAN 50. No shut that bad boy. He's probably already no shut. We'll show VLAN brief. I hope I did a long synchronous there. So he's in that VLAN. They also said for task 3, allow also configure router 1, this guy right here, to allow Telnet using the password Cisco, which we just like last lab, right? A lot of this stuff is from last lab. I think tomorrow I'm gonna skip this part right here. I'm gonna go skip it. I'm just gonna do it offline. So all the IP addressing and the interface VLAN, the SVIs, creating all of that, we're just gonna do the last couple tasks and so we can just focus on natting, because y'all know I'm pretty, like, if y'all been watching this stuff, y'all pretty sure y'all know how to do this stuff by now. But if not, just go ahead and ask some questions. Either way, you can do it. My bad. We got my equipment over here falling apart over here. He said you can do it. It will be a static statement. IP ID, IP not inside source, static, blah 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 blah, or whatever the case may be. Okay, so similar to what we did with the static lab, we didn't add a port number. We just did the static. We just mapped the public to the private, and then we just left it as is. So same thing what you just said, but you're adding the port number. I didn't know you could do that, but that's good to know. I never did that, static ports, or maybe I did. See, I need a review too, Joseph, man. It's all good though. So we did the VLAN, we put that port in that VLAN, and then they said to configure router 1 to allow Telnet access, right? So we want to not allow Telnet, right? So we'll go to switch router 1, allow Telnet access on the VTY lines. So let's get out of this. Let's see if that interface came up. Show IP interface brief. He came up. He sure did. Good. So this right here, this interface is up. Good to go. We don't have anything else on these guys. That's all we needed, right? So let's go to global config mode and allow Telnet on the VTY lines, VTY 0 through 16. And then we're going to say password. They said the password need to be all caps Cisco, just like LiveLabs, man. And then we're going to do login to check for the password. What else we needed to do with that? Let's do a show run section line. And we need to allow Telnet. This is why we always need to run those show commands in the middle of our work, right? See, I forgot about that. 0 through 16. We're gonna say transport input Telnet to allow Telnet, right? Show our work again. Now we're allowing Telnet. We got the password Cisco, and we're gonna check for the password right there with that command. And we're doing it through 0 through 16. All right, good to go. Task 4, configure interface VLAN 50 on switch 1. So they want us to configure this interface right there, right? Just like LiveLabs, I don't know how many times I'm gonna say that, right? I guess I kind of like the book that they use the different topologies. That way I got to change up the cabling and do all of this other stuff, right? But sometimes you get a little too familiar with it. They just want you to focus on the concept and stuff like that. So interface, not that device. Switch 1. Interface, when you go config mode, interface VLAN 50, and we want to give him the IP address of 10.2.2.4/27, which is 255.255.255. Not 240, but 224. And notice that it's down. It's down, right? Let's show our work, show IP interface brief, and then let's exclude unassigned. See what we got so far, 10.2.2.4. He is up, down, most likely because we don't have this guy. We don't have that guy up with this guy right here, right? Did we do FA00 on that other switch? Let's check. We did 0.0. Nope, don't look like we did. That's why. So look at this. Show IP interface brief. Yeah, so FA00, this guy right here is not up. He's down right now. So we need to fix that, and then that should bring up the interface VLAN on the switch, right? So we go to global config mode. We say interface FA00. We give him the IP address of what? 10.2.2.2. We said /27 is 255.255.255. Not 240, but 224. No shut that bad boy. Show IP interface brief, our favorite command. And now that interface is up. Let's go back to the switch. And now FA0102 is up. We should, let's see. Spanning tree is blocking that port right now. So it's up, but spanning tree is blocking. So as soon as that is up, I'll let y'all know. This is why I love hardware, because you can actually see this stuff, all the blinkety-blinklies, and watch it go. So I'll let y'all know it's still amber. Y'all know spanning. Now it's green, and now it's up. See there? Just little things like that. I believe packet tracer, you can see the lights and stuff like that. GNS3 definitely doesn't show you the lights and stuff like that. Just little things like that. The little nuances that let you see, like, this is how it works when you physically see it. But, if in case you're in a quick pinch or you just can't afford hardware, old-ass hardware like this, why is spanning tree blocking anything? Well, spanning tree, just in case there's any loops that can happen. That first couple seconds, spanning tree, depending on which flavor spanning tree you have, it will block any kind of forwarding, no matter what it is. And then once it sees, it checks... it depends on which flavor of spanning tree we got. I believe I'm running rapid spanning tree on this. I believe that's the default anyway. Show span RSTP. No, I'm running just classic spanning tree. I believe that is. I believe that's classic spanning tree. Correct me if I'm wrong, Kelvin. But yeah, I believe I'm running classic spanning tree there. And it checks to see if anybody else is root and stuff like that. And then it goes through the election process and all of that. And then finally says, okay, I guess I'm the root. So I'll go ahead and start forwarding, and then he starts forwarding on on all of his root ports or whatever. On all of his ports, actually, since he's the root. So that's what spanning tree blocks for. Never mind, we're good. This guy didn't read my other messages. Oh, let me see. Why is spanning tree? Is that what you're asking me about spanning tree or the port, the natting question? I don't know. You going off in that chat over there, man. I'm trying to keep up and talk at the same time. That's why I said if I can't answer, there's some smart people in that chat room that are able to answer as well. So I'm trying to, I'm trying to lab and do this at the same time. You gotta understand, being a YouTuber ain't that simple. But anyways, it's all good. Task number 4 still. We did the interface VLAN. We assigned the IP address to it, right? Did we assign it? Yes, we gave him the correct IP address, 10224 /27. What else did we wanted to do there? This is just like yesterday's lab. They wanted us to, the default gateway. So he got to have a default gateway, and it's going to be this guy right there, 10222. So when he need to get out, he's going to use that as the default gateway, right? Y'all remember how to do that? And remember, once we get to these, I keep saying that. I know I've been saying that for the past 10, 15 labs, but I'm just getting people to catch up to all of these simple tasks right here. Not simple, but at least stuff that they may or may not know. And then once we get through that, I'm going to do this stuff off screen, and then we'll just get to the nitty-gritty of what we needed to do. So that's going to be his default gateway. We can verify that with, I don't believe you can do that with show IP route, because he's not routing right now. Oh, yes, you can. Good. See, so you do show IP route. It'll let you at least know his default gateway is that, but route cache is empty because routing is not turned on yet, right? And it's not going to be on because we're going to leave it at a layer 2 switch. What they wanted to know here. That was task 4. Task 5 is to test connectivity, which I'm pretty sure should work, right? Test connectivity by pinging from router 1, this guy right here, to router 3. So they want us to ping from here to there, just like that. And pinging from router 2 to switch 1, which in my case, router 3 to switch 1. So they want us to do those testing. We're going to test that one first and test this one second. Let's go ahead and do that. Let's go to router 1 and ping 192.168.254.2. Pray to the network guys. We got to reply. And then go to router 3. Remember, the book was they just wrote it differently. I don't know if that was a typo or what. Or maybe they just forgot to make him router 3 or router 2 in the book. Maybe that was from the last version of this book. No, this version got it too. This is the hard copy book of this book. In case y'all don't know, if you're just tuning in, this is the book we use, 101 Labs, Cisco CCNA version 4. You get a copy of this from 101labs.net, or there's a link in the description box below. It is an affiliate link, so I do get commission if you do get it. And you help out this channel when you do that, man. So now we have router 3. Excuse me, ping router switch 1, which is 182.160. I'm sorry, what am I doing? Switch 1 is actually 10.224, right? 10.2.2.4. Pray to the network gods, and we're just hanging there. We got a reply, 60%. Good. Let's try it again. We got a 100%. All right. So next task was same task. Task 5 says these should all be successful. However, since router 1, this guy right here, does not know about the 10.2.2.0 subnet, which is this shit right here. So he don't know about this network right here. Why? Because we don't have any kind of routing or anything enabled to that. He's a remote network. So we got to do some kind of, they didn't tell us that in the past couple streams, but remember that first stream when I got stuck, I was like, what the hell's going on here? Oh, duh, he ain't got no route. So we got to make him have a route. Because remember, this is a remote network to him. He don't know about that network. He's not directly connected. He's directly connected to this network, but he don't know about that one. So we got to create some kind of static route, or EIGRP or OSPF or something. But we're just going to keep it simple and do a go to router 1 and do that, and configure a static route, right? So we're going to go to global config mode and say IP route. What we said, quad 0. Just like yesterday's lab, man. Just like yesterday's lab. Matter of fact, I've been living the past 3 streams. We just haven't done anything different just yet. Y'all hold your horses. Hold your horses. We're going to go out of 000 for any kind of traffic that we don't know about, right? Check our work with show IP route. And that is our default gateway now, right? S lets us know it's a static route. Star lets us know it's a candidate default. So that's pretty much it, right? And then now let's see if we can ping anything in that gateway. We should be able to, right? Ping 10.224. Yes. Okay, so this worked now. That worked now. Good to go. Let's put a happy face there. So he's good to go. Task number, and then they said switch 1 will not be able to ping router 1 or vice versa, but he should now, being that we created a static route. Let's try that though. Let's just try. Let's just for the sake of completion, right? Or sake of complete complexity. I don't even know what I'm trying to say here. 192.168.254.1, and he's good to go. All right, so we ain't even had to create a network, guys. It just was good to go. Task 6, what we came to do here. We only got 8 tasks. It's only task 6 right here. He said should be PVST plus. That's what I thought, but IEEE, I believe, is class expanding tree. He said I clock into a server every day, not a switch or a router. These labs are making me want to pull a Tommy from Martin and say, screw this job. I want an engineer job, man. Hey, man. I mean, do you, what kind of, like, if you, I wanted an engineer job for a while as well, man. It wasn't until recently, you know, I had a contract role and stuff like that, and they hired me on as an engineer. But I finally was able to land the role. They wanted me full time, and I finally got the job and stuff like that. But it took me a while. I worked in the NOC for a long time, and then finally got the role and stuff like that. I worked with recruiters, so that's one good thing to do, because recruiters can kind of get you in the door. The only thing is they got to get a cut of your pay. So if you're willing to take that cut, and you know, you're able to get to their screening interview, they'll vet for you. They'll kind of like, hey, they'll vouch for you and stuff like that. Be like, you know, he's got this kind of background. We've already done the background check. You know, just hire this guy. You know, they kind of like speak for you in a way, but you obviously got to pass the interview too. So recruiters is one way that definitely helped excel my career, man. So try to find a recruiting agency. You're in Australia, right? Or no, you're in Jersey. I believe you're in Jersey. There's definitely some in Jersey. Matter of fact, I got a one of my moderators is, what's his name? CLI Soldier. He is in Jersey. I believe he works out of New York City and stuff like that, and he transports back and forth, but now he's working from home for a fintech company. Yeah, I'm in a NOC. So I was in NOC too. Yeah, work with a recruiting agency if you could, man. Tech Systems, Apex, there's a whole bunch of them, man. Robert Half in technology, there's tons of them out there, man. Definitely work with a recruiting agency. They were the ones that helped excel my career. So task 6 was to create an ACL, or access control list, to permit only, now this is where I got stuck, because I forgot that you could add, I mean, I knew that you could create an ACL and block more than one protocol, right? Like you could block, let's say, OSPF traffic if you wanted to, or, you know, any other port, like SSH traffic, if you wanted to block that if you wanted to, or allow only Telnet traffic, which God forbid you would do that. But, you know, especially extended access lists are so granular, you can block any kind of traffic or allow any kind of traffic from a specific network to a specific network, right? But I forgot how you can add more than one protocol. And this is where I kind of got stuck before I said, you know what, let me go ahead and stumble through this during the live stream. So task 6 says to create an ACL to permit only Icmp. Y'all know what that is, right? That's basically ping. It stands for Internet Control Message Protocol? I can't even remember. Let me not make this shit up, man. Actually Google the shit, right? For the network, bro. I ain't watching this guy. He don't even know what ICMP means. I know it means ping, damn it. For some jackass come in the comments and let me know. Internet Control Message Protocol. Is that what I said? Is that what I said? But that's basically what we want to do. We want to allow only that traffic and telnet traffic from the 10.2.2.0 subnet to any destination. So this subnet right here, this is the 10.2.2.0 subnet, right? Because he's .2 and he's .4, right? This is the 10.2.2.0 subnet, right? Any traffic from here, we're going to allow only telnet when he's coming out of here. We're going to allow only telnet and an ICMP, or basically ping. Y'all like my third grade writing? My daughter write better than this, man. From the 10.2.2.0 subnet to any destination. So we're going to allow only this kind of traffic to come out of this interface to any destination, to anywhere we're going to go. So it don't matter where we send our traffic to out there. As long as it's telnet and ping, you can exit out that interface, right? You can create either a named or numbered ACL to complete this task. So I know we haven't got to the port address translation yet. They got us doing ACLs because usually ACLs work in conjunction with NAT. So that's why they got us doing this first. So let's go ahead and go to router 3 because we know we're gonna do that, right? On the this is basically our our edge network right here, right? This network, this device right there, right? So configure terminal, and let me read that back. Create an ACL to permit only. That keyword right there, permit, lets us know we're gonna have to start it with that, right? So IP access list, right? Access list. I'm gonna do a question mark because I can't remember them all by heart, right? So we know it's gonna be an extended because they ask for a source and a destination, right? Because standard access lists only do destinations, right? Or source. No, I keep forgetting that. Let's double check that, because extended you can define the source and destination. Standard ACLs define, they evaluate only the source to where you're coming from. That's all you can check. Extended is from and to. You can define that, right? So in this case, we're going to do an extended access control list. They said we can name it, or we're going to do a number. Well, I'm going to do a number. Let's go with I don't know. Let's do 105 today. I don't know why. I don't know why I picked that number. So we do that, and we're going to go to extended numbered access control list configuration mode. Say that 5 times. What's the first thing we're going to do? They said we want to permit the traffic, right? So we're going to allow only certain traffic coming out of this way. That's what we're saying there. Okay, fine. Permit. That's the keyword. Easy enough. Permit what? They said permit Icmp and Telnet, right? This is where I got stuck because I was like, how you do both of them? Yes, both of them. BOFFUM. How you do both of them? I forgot how to do this. So, and I remember there was like an EQ at the end, and you had to put either a port number and stuff like that, but I couldn't find it, so I was like, man, fuck this, man. Let me just do this later. So, we're going to permit, we know that we're going to permit, we said Telnet, and notice Telnet's not in here, nor is, there's Icmp right there, Icmp. So, we got to do that. That's ping, basically. Internet Control Message Protocol. So, we're going to permit that. What are we going to do it from? From source, they said what? The 10.2.2.0 subnet. That's something there. So, we're going to, anybody from here to go that way, out of this interface, right? That's what we're doing there, right? So ICMP, the 10.2.2.0 subnet, so anybody in that subnet, not just one specific course, host, I said horse. The wildcard bits, y'all remember how to do that, right? It's 255 minus the subnet mask, right? So in this case, 255 minus 0, or 255 minus 255 is 0, 255 minus 255 is 0, and then 255 minus 255 is 0, and then that last octet, which is the interesting one, is 255 minus what's the subnet mask, right? The subnet mask was 255, 255, that's the last subnet. That's the interesting octet, 254. So we're going to say 255 minus 224 is 31. That's the wildcard mask, right? Yeah, I remember how to do that, right? It's basically 255 minus whatever the subnet mask is, right? So dot 31, and then what else they want us to know? To where? We said anywhere. That's what that is. So easy enough. Any, right? Press that, and what else we got? And this is where I thought, okay, maybe I got to add the Telnet to the end of this and all that. No, you just got to create another entry for this access control list, right? So that's what we're going to do. We're going to say any and stay here. That is that one. We're going to do another one. Permit Telnet. Can you do Telnet there? Nope. You can't do Telnet. Oh, Telnet is a type of TCP traffic. That's what it was. So let me show y'all real quick. And that's where I got hung up too. In case you got this book, there's a solution guide as well. So if you get stuck and stuff like that, solutions in the back. He said, I was dealing with Texas, New Jersey. All is good. After a year of this job, I'm looking for another. That's what's up, man. Texas helped me land one, my first like actual hands-on role. They were gonna have, work with me to get a knock job and stuff like that. But I was like, they couldn't even, they act like they didn't want to help me. So I got it my own. So he said, hey, I'm late to class. It's all good, Pete. You can always replay this, man. Look at everyone else. Get website, start blog, log your learning process. Damn, giving a recruiter my money, especially in Jersey. What you mean, man? These ACLs are fun, just not on the exam. I know, man. ACLs are they're pretty trippy, man. So he said still with test systems. That's what's up, man. Check out tech systems from Jersey. See, yeah, exactly. I was able to work with them now. Now I'm living in Georgia. That's what's up, Dave. I didn't know that. Engineers fun, lots of fixing. Yeah, I'm in Jersey, but I'm moving. Yeah, that's the homie. Yeah, man. I think he's in Jersey too. I don't know how far he is from you, but he was able to land a fintech job. And I don't remember if he did it with a recruiting agency or not, but yeah, he's doing pretty good. He's doing pretty solid over there. So, anyways, we said, notice we did the ICMP, which is ping, right? They said Telnet, right? Notice Telnet is not on here, right? Well, guess what? Telnet is not an IP type of traffic. It is TCP. Or it's not UDP, it is TCP. So that's the other thing too. You gotta remember that some of these protocols and stuff like that. I kind of forgot about this because I remember doing some labs in like Bosa NetSim, and they ask you to define to filter Telnet traffic. You got to remember that is TCP traffic, right? So you do that. Source address was what we said. We're gonna do a source network 10.220. Subnet mask, which we already done. 00031. And then that's where I got stuck. I forgot about this part right here. This is how I couldn't remember how to find it. So match packets on a given number, port number, or you can do. Actually, I believe you could just type in, right? No, you can't. There's some. I thought you could do that. No, I think you got to put in EQ and then the protocol. That's what it is. So you put in EQ and then the protocol. You can either put port number like this, or just type in the protocol. So in this case, Telnet. So now we do that. Nope, looks like I forgot something. What did I forget? Equals Telnet. Port number. Oh, you know what? This was EQ. So this was let me verify that. So this is the destination. This is the source. We're doing equals Telnet. And what else we got to do? Oh, I believe this is the destination. So you got to put that towards the end, I believe. Okay. Let's see here. How come you can't just enter there? I thought you could just do that. Let's do this. Let's see. After the IP address, that's the source. I didn't finish that. So we did the source. I forgot the any keyword. That's what it was. Destination, any. And then you do EQ. Can you do that there? Yes. EQ. And then the port or the protocol. Telnet. That's what I was looking for. So now that I've done that, right, I've added basically two definitions to this, or two rules to this access control list. To show our work with show access lists, right? No, that's too ambiguous. You don't like that. Access list. Jeez. You want me to type it all out? Okay, that's our access list, right? So the access list lets us know we're going to block this, or we're going to permit this traffic, and also permit this traffic as well. There's also something that happens at the end. There's something that is implied at the end. What are we implying at the end? That's another pop quiz. We're saying we're going to allow this traffic. We're also going to allow this traffic. There's also something that's also implied at the end of that. What is implied? EQ, correct. EQ Telnet is at 23. So yes, you could also put 23 or Telnet. What happened was I forgot to put the destination. Yes, exactly what Pete said. Destination. So that's pretty much it for that. What is implied at the end of this access control list? Y'all remember? Do y'all remember? That is a CCNA fundamental. We'll do it again. Show access list so you can see it clearly. That is what the access list is. So this is going to block ping or allow ping. This is going to allow Telnet. And there's something else that gets implied at the end. What is that? Pete said it. That's correct. The implicit deny all. So we're going to allow this. We're going to allow that. Anything else, you're going to deny it. So that's called the implicit deny. Exactly, Pete. Yeah, Joseph, Pete just said it correctly. It is the implicit deny that is at the end of every access control list. What else they said? So that was task 6. Task 7. We only got 8 tasks today, so we only got 2 more tasks. But these are pretty tricky here. So he says here, configure router 3, which is this guy right here. FA00, that right there, as the inside interface for NAT. Oh, we did this yesterday. So this is going to be the inside interface, right? Inside. And then they said, and S00, or in my case, 000, that right there, as the outside interface. So that's outside. This is inside. Right? I know my daughter writes better than this. Y'all give me a break here. Go to global config mode, and we know how to do that already, right? We did this, I believe, yesterday. Interface, what? FA00. And we're going to define it with Ip Nat inside. And then it's going to create that NVI 0 interface, right? Which was, I keep forgetting what that is, but it's basically used for, it's an interface that's created when you're doing network address translation. But like we said, it's kind of a legacy, I guess, interface, if you want to say. Because remember what our interfaces looked like before, right? Let me get past all this and show y'all. When we did show IP interface brief, when you had these 3 interfaces right there, right? 2 with IP address, 1 non-assigned. Now if we do show IP interface brief, I need to turn on login synchronous. I keep forgetting to save that. Show IP interface brief. And not only do we have those 3 physical interfaces there, but we also have this virtual interface called the NVI 0. And I keep forgetting what that is again. I'm gonna keep looking it up until I remember it, man, and keep telling y'all until I remember it. What is the NVI 0 interface? When you enable NAT, legacy or not, the iOS enables a virtual interface called NVI 0. This interface is used only when the IP NAT enabled, or in my case, IP NAT inside, is enabled. This interface can be found with the command show IP interface brief, which we just looked for, blah, 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 blah. It's the non-virtual interface that's used for NATing, right? So that's created. Now we're going to go to this guy right here and create the outside interface, right? This guy right there. So that is the 000, right? Interface 000. We did FA00 as the inside. Did we? Yes, we sure did. Show, I'm sure, what am I doing? IP NAT outside, right? So he's going to be the outside interface, right? And this is how we kind of defined our boundaries when it comes to NATing, right? We saying where's the outside, where's the inside. That's basically what we're doing there. Stole my thunder. Yeah, man. You gotta be quick on the draw, man. We got some smart people in this room, Joseph, man. You stole your thunder there. IP NAT. He said up outside. I'm pretty sure you meant IP NAT. This is real, as in you'll see it in production. Yes, man. Trust me. When I was studying for the CCNA, I've never seen that. I remember, playing with Packet Tracer, creating NATing rules and stuff like. I've never seen that. And believe it or not, that is a legacy interface. I have yet to. Yes, you'll see it in production. You will, depending on what version of iOS you're using. Trust me, I'm befuddled. It's just as you are, man. Is that a real word? I mean, it's real world, but I forgot what that meant. But anyways, yeah, I don't think I remember seeing this, man. So, yeah, so. Yeah, this is something you'll see. And this is why, like I said, there's no way I would work on trying to get my CCNP and not know little shit like this, man. So this is why I'm going back and filling in the gaps in my knowledge, man. Just little things like that, man. Because if anybody got Packet Tracer, if anybody's watching this stream right now, if you're running this lab with us using Packet Tracer, let me know if that interface gets configured or if it gets created. I don't know. So I don't remember even seeing it, man. And studying for UC, I don't even remember like running into that concept, man. Believe it or not. So, and like I said, this is why I'm going back and filling the gaps in my knowledge before going back to CCNP studies. So, configure router 3 is the FA. We did the inside, we did the outside interface. Next, configure PAT, or port address translation, to translate all IP addresses specified in the access control list. You configured in task 6 to the S000 interface of router 3. That was my fault. I want to just go ahead and look straight to the solution guide, but I'm going to go ahead and give it a try and look at what they said. Try to decipher it, because that's how it is when you're taking, like, these tougher exams and stuff like that, where they ask you to actually do some configuring and stuff like that and actually try to, get it hands-on. So let's see here. It says to configure port address translation to translate all IP addresses specified in the ACL. So this is going to be similar to what we did yesterday, except I believe we are going to add a port number. So let's do this. Let's go to global config mode. We know that for sure. And they said that we're going to do this. We need to map the ACL that we created over here, right? We created an ACL here. And they said they want us to translate all the IP addresses specified in this ACL. So there were some IP addresses that were specified in here, right? We'll just put IP just like that, right? And then port address translation is going to translate all the IP addresses in here. And when he comes out of this interface, he is going to use a public IP address with a port number. So he's going to use this number and affix a port number to it. Let's say, I don't know, we'll use Joseph's favorite number, 80, since he knows that one by heart. HTTP, right? That's my first time seeing that interface. Doesn't show an EVNG. You got to be kidding me, man. Please tell me what version of iOS you are using, because this dude has been trying to get me to get an EVNG. And you know what, though? EvenG uses a newer version of iOS. I think that's the reason why. It's all good though, man. It's all good. If I'm not answering them, I know Kelvin will, because you know you have all the answers. Anyways, yo, what's up? I hit you up on Twitter. I haven't been on Twitter in a long time, man. If you know, man, I've just been focusing on live streams. If I get a chance, I'll try to go on Twitter and answer or whatever it is. But anyways, if you can't hit me up on Twitter, hit me up on Discord. I usually have that on in my phone, on my cell phone. So even if I'm at work, I will answer it that. NVO is a back-end thing. Yes, exactly. NVI0 is a back-end thing. So, but it does some translation for you. But like I said, I've never seen it before until I started doing it. So, what we said he was going to do here. Configure port address translation to translate all the IP addresses. Okay, so we might need to. I definitely need your help. So I don't really need it then. No, you might not need it because it's kind of like going by the wayside. It is legacy. And you will maybe see it in production, depending on what version of iOS and stuff like that you're using. But if you're not seeing it in EvenG, it's because it is a newer version of iOS, and they kind of, like we said, did away with this this interface here. And I'm using some pretty old routers, but they are version 15.1. So, but yeah, exactly. You don't need to worry about it. So, okay, we said we got to do Ip Nat. I think that's definitely what we got to do here, right? All right. So what we got to do here? We're going to definitely do a source address translation. I know that. We're going to do inside, right? We got to do inside. I believe we got to do inside, right? Because they said here, configure router 3 FA00 as the inside NAT interface. We did that. S000 as the outside NAT. Next, configure PAT to translate all the IP addresses you specified in the ACL. You configure the task 6 to the S00 interface. So, guess we got to do Ip Nat outside. We're going to do some outside address translation. And then the source address is coming from a list, right? Notice how I'm kind of like talking myself through this because I don't know these commands by heart. Even I don't remember who it was I was watching earlier today. It wasn't Kevin Keith Barker, but it was another guy. I believe he's soundtraining.net, and he was explaining to me ACLs. He was like, no, Rick Graziani. He's a professor out of some school in California. I can't remember, but he teaches this stuff. And even he said he's been teaching stuff for years, and he can't remember the syntax for natting and stuff like that. So notice how I'm question mark, and I'm kind of talking myself through it. So Ip Nat, we know we're gonna do an outside translation. Source from the access control list. What we said we created access control list 105, right? And then what? Pool. We didn't create a pool though. That's what I'm confused about now. We didn't create a pool. So let's see here. Translate all IP addresses specified in the ACL. So is that just it? We don't have to put the pool? Just like that? Nope. Nope. We got to configure something here. Something else here. Let's say pool. Let's just do that. And let's say pool. No, we didn't create a pool. So that's what I'm confused about. All right. So let's see. Might have to go through the solution guide. I'm trying to just kind of go through it too. That should be an FA00. You say NetworkBruh. EvenG, GNS3CML use the exact same version of iOS because the platform doesn't determine the software version. They're just hypervisors. Okay, good to know. Outside source. Your lab uses outside source? I doubt that. Let's see. Let's see. It's probably inside, but let's see. Let's see. Nope. You're right. You're right. So it's inside Ip Nat inside. Okay, I'm glad you're here, Kelvin, because I knew it was gonna be tough for me. So we gotta do. It's not outside. It is inside. I'm glad you said that. So it's inside translation. So now that's what I'm confused about. How do you know whether you need to do outside or inside translation there? If you have the answer to that, outside source is very niche. Okay, yeah, because you're not gonna be translating an outside IP address. Is that what you're saying there? So it's inside. We're translating from inside to the outside, and then source, right? The list is list number 150. Specify the interface for the global address. They said the interface 00 interface. So this right here. So when we're leaving, that is the interface right there. He said, simple. If you need to ask, you're doing inside source. So you need to ask, you're doing inside source. Because I assume that's where the hosts are. Okay, so yes, inside source. All right, good to know. That's what I need to remember then. Like I said, like this ain't new to me. It's just it is old to me. So this is more a review and a refresher for me, and this is the parts that I'm getting stuck at. We're at Lab 65 here, so give me some kind of credit here. So let's do that. Right. So he said it was definitely inside source, just like you guys said, and I'm glad Kelvin you're here, tuned in. So we're gonna reference the source. It's not 150. I take that back. We created source number 105. Typo. Fat Finger Squad. That's why they call it Fat Finger Squad. So it's 105. Glad I checked myself there. And then the interface, and then they said interface 000, which in my case 000, right? So that right there, serial 000, and then that right there, overload and address translation. That is the keyword that is going to let us do port address translation. When you put that keyword overload, now that I remember. And then what after this? What else can you do? No payload, none of this. Nah, that looks pretty superfluous. I think that's pretty much it with this. Does that look pretty good to you, Kelvin? He said, because I assume, yeah. I think that's pretty much it right there. So I need to remember that it's inside source that you're mostly going to be working with and not outside source. But yes, what I was thinking, because I know you said outside source is pretty niche, but why would we not, when would we use the outside source list? Because yeah, that's true. You're not really working with the outside IP addresses. So I don't know. Just writing that statements, they just don't seem too intuitive to me. I don't know about y'all, but it just don't. Ip Nat. The inside source is coming from the list 105. If that's what it's saying there, I don't know. But I mean, that's basically what it is. But I'm just trying to piece it together, kind of like what Visual Basic does, right? Visual Basic is probably the most simplest, in my opinion, from back in the day, computer language. But I guess that's all we needed for that guy, right? Let's check our work with show IP. How can we do that? Nat Translations? We ain't gonna have no translations. We got to do statistics to actually see that, right? To see the list. Yes. So we got the access control list 105. None have been allocated yet. Oh, it's not going to show that. That's dynamic address translation. We don't have any hits or misses yet because we haven't sent any traffic yet. So as soon as we send some traffic going through there, it should theoretically see some hits and misses and translations and stuff like that, right? So he said, yeah, overload is a must. Don't remember you creating a pool though. Yeah, I didn't create a pool. What I was thinking of was what we did yesterday, dynamic addressing, and we did it with a pool. So outside source might be if you're hosting a server. Yeah, that sounds about right too. Man, you seem to know your stuff, man. I don't understand how you having difficulty with that. But anyways, you are pretty much a lot of help, man, so far. So what else we needed to do here? Task 8, I believe is the last task, right? We configured the IP NAT statement. I might have to do these. I need to do more natting every day. So that way I can remember this stuff, man. Because this is what trips me up. Natting and ACLs. Ping router 1 from switch 1. So we're gonna have switch 1, ping router 1. Also perform a telnet from switch 1 to router 1. So we're not only gonna ping him, but we're also going to perform a telnet. Right, so let's go have switch 1. Let's go to switch 1 and ping that guy, right? Ping 192.168.254.1. We got a reply. Good to go. So we're allowing that. What else they wanted us to do? They said, well, I said maybe. I'm not 100% about the hosting server part. But yeah, I mean, that sounds about right, though. That sounds about right, because you're doing some outside IP addressing. Let me see here. He said also perform a telnet. If you have configured interface-based path correctly, the ping and telnet should work. Okay, so that's a good sign because so far ping worked. Let's go ahead and see if we can telnet to it, right? Pray to the network gods and telnet to 192.168.254.1. And we're getting prompted for the password, all caps Cisco, because we chose a very secure password. And we're in. Good to go. So looks like we finished the lab. Last part of the task, though, says check the NAT translation table on router 3 using the show IP NAT translation. So now we could do what we did before, right? We did show NAT translations already, but it was empty, right? Came up empty because we didn't have any traffic. But now that we sent some traffic, this guy should theoretically see some traffic down there, right? Some traffic, and he should be able to translate some of this stuff right there. Y'all know I like to do my little third grade drawing, especially when the ping works. He said that's exactly what I was going to tell you to check. Yeah, so let's do that. Show IP NAT translations, and there we go. We got a translation there, right? And this is what the part that used to trick me out, and I'm going to keep telling y'all this until I remember it too. Because like I said, I go back and watch these streams and remember, oh yeah, that's what this is. That's how you create the ACL. That's how you create the NAT and all this other stuff. Yes, I'm crazy. When I go to work, I watch my streams over again. Notice this is an hour. We reach that hour that we normally reach. It takes me about 30 minutes to get to work. I watch half of the stream going to work and half the other half coming to work, coming back home. So if you guys want to follow along next time, this is the book we typically stream from, or get our labs from. 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. There's also a link in the description box below. It is an affiliate link, so I do get commission. Experts agree that we retain only 10% of what we read and 90% of what we do. That's why I love this book and stuff like that. So let's go ahead and break this stuff down and then call it a night. We said, notice that there's an inside. This is what used to trip me up, right? Inside global, inside global, inside local, outside local, outside global. Shit sounds kind of contradictory, don't it? or like what's the word? Oxymoronic to us, right? But we got an inside global. What the hell is that, right? Well, let's do this. Since this we know is our local area network right here. This is our local area network. This would be, I guess, the wide area network, right? This is the internet right over here, right? And then we're gonna create a what are we gonna say? You would think because we did the ACLs, we would put the borderline right here, right? But no, we're gonna create like kind of like a demarcation point like this, and say that this is our WAN right here, right? And this is the LAN coming out of this way, right? Right? And there's a reason why I put it there. But don't always use that as the demarcation point, because when you work with other stuff, like with the when we did the outside interface and the inside interface, right? Your demarcation point for that would be that right there, right? But not for this case, right? When we're doing the inside global and inside local and all this other shit right here, this is how we're gonna separate it, right? At least I will, right? When we say inside global, think of the word global, right? Well, where's the global part? He is on the wide area network. So actually, you know where we need to put that at? Let's do this. Yeah, I guess that kind of is in a way. No, I'd rather do that. This is inside and outside, right? So we're saying this is going to be the global part, right? So it's out in the wide area network, even though I put it right here, but it's on the inside part of the inside router. So let's call him the inside router too, right? And he's the outside router, right? So this is the inside global part because it's kind of like in the wide area network. So I guess what I really want to do is put the I guess I want to put the interface, kind of like put the split mark right over there. That's where I really should put it. Let's do that instead, right? Let's put it right here. All right, so this is the inside global right here, right? So when he leaves, he's going to get the address 192.168.252.2, right, which is this right here. But he's going to affix a port number to it. That's going to make him unique when he leaves out of the interface, right? That is the inside global part. IG. Now, I'm not talking about that little social network. I try to stay off of it. So you said, Jesus Christ, man, you give me a lot to read here, man. Don't remember you created a pool. Don't know, I didn't. Outside source might be if you yeah. Well, I said maybe that's exactly what I was going to tell you. Check. You have to have both CLI open. You think so? You drive to an office? No, I'm at home too. But sometimes I got to go on site to do some racking and stacking, or something's broke. But yeah, for 90% of the time I am at home, and I do got to drive to work. But yeah, so that's the inside global part, right? FA00, or so inside local is going to be the hosts. So in a way, he was a host, right? 10224, right? Notice right there, 10224. but we also what? Affixed a port number to it, 54986. That's called the I believe that's the ephemeral port number. That's what they call it, right? Right. So remember, and then so he is basically the inside local guy. That's what that's telling us. Inside local, that is the address for it. When he leaves out of the internet, this is his inside global address. And remember, when we put an IP address together with a port number, that's called a socket, right? That is a socket. So that's basically his socket, right? When he leaves out of the internet, coming out this way, right? And then we got two more to define here, and then we'll call it a night, right? The outside local, right? Since this guy is the outside router, right? He's outside, right? If we had a host out here, if we had a host in here, out here, somewhere back here, like a server, like Joseph B was mentioning, this would be the outside global address, right? OG, not original gangster. How many times I'm gonna say that joke, right? And then this part right here, outside global, right? Since this is the wide area network, right? That was the local part right here. Oh, my bad. This is not outside global. This is outside local. Sorry about that. This is outside local. Sorry to confuse you. This is outside local. So because this is kind of like this is in a way his local area network, right? Because remember that's his local area network. Once we get out here, this is the wide area network, right? And then this is our local area network. This part right here, right? This is our local area network. So this is the OL, right? Or OL. The outside local, right? And then this is gonna be the outside global. Since there was not, we don't know what the other devices. They just gave it the same thing. Port number 23. So when he's coming back, why you say I needed two windows open? What were you talking about? To see the address for the other device? I can't remember. But we gave him the TCP traffic, that port number. But you would think maybe because it's the same host. I don't know. Because when we said that, when we sent the ping, we got some hits there, right? Where was that? Where were the hits at? They not in the show IP address. It's not in the translations. It's on the statistics. Here's where the hits are. We got 46 hits. We sent some ping traffic, and then we sent some telnet traffic, right? That's basically what that is, right? Now, what I wanted to see was since TCP, this is basically our ping traffic. No, that's our telnet traffic. What I wanted to see was what the ping traffic would be, but I think that's going to be the same thing. I would have thought, because this is what that's not professional, that's protocol, to let us know what that is. That's the protocol, and then that's the socket, right? What I wanted to see was what happens if we send TCP. What TCP is that the ping or is that the Icmp message? I believe TCP was we got to look at our access control list. TCP was the telnet, so that was when we telnet. What I wanted to see was what the ping address would have been. And I think that's probably the same thing, right? Yeah, that's the other thing too, right? Because it was when it came back to us, 23, port number 23. So when he came back out, he used port 23 to get back out. That is what is the outside local and global. It's the same thing because we don't know if there was a host back here. We don't know his private IP address, so that's why they gave him the same thing. Right? That makes sense. He said, I like to track the translation as they go. That's why I said to have two windows open. What we could also do is debug, actually. So good point. We pretty much wrapped up the lab. We are over the hour. If y'all want to stick around, I guess we'll do some debugging to appease Joseph over there, since he wants to see the traffic. And I think, I don't know, let's read the notes here. Port address translation, or NAT overload, is enabled with the overload keyword, which is what we did, in the Ip Nat inside source list command. This allows the router to overload address translation to the specified interface or IP address. Do not forget to issue this keyword when configuring path. Otherwise, you have created a dynamic NAT and will run out of addresses after the very first translation. Notice that there is only one translation. Notice that there's only one translation for Telnet, but there are 5 translations for ping. Good to know. So let's do that ping again real quick. We're gonna have we'll have the switch do that ping again because we did the Telnet, but let's do the ping real quick. So we're gonna have him ping, which I did already, but let's do it again. So we're gonna go to switch. And we did the Telnet. Let's ping. We sent 5. Let's ping it again just to verify. Now let's look at our translations. And there you go. That's what I needed to do. I needed to do it again. So on ICMP right there, you see that? That's the ping traffic, right? ICMP, and then as soon as we Telnet, oops, maybe that's what you wanted to see right there. We'll do that. You want to do a debug Ip Nat. Who we got to do that from though? From router 3. That's probably where we got to do it from. Debug IP what? Nat, like this. Now is Nat's turned on. Let's Telnet and take a look at that. Telnet 192.168.254.1. Take a look at that. Boom! Look at that. Let's close this real quick. Well, let's go ahead and log in real quick. Cisco. Enter. We send some more traffic. Boom. Right? That's probably what you wanted to see there, Joseph. We're gonna. I want to disconnect from him. I just want to. Let's move him over. Right? Let's go back to router 1. No, not router 1. Router 3, and there goes some even more traffic. It's expiring. So once our Telnet times out, where's the Telnet? Once that, oh, there it is. It timed out, right? And that's what that was right there, expiring. So we got some more traffic here. Let's go scroll to the top. We got our source 10224. Who's that? That's this guy right here. So he's the source, right? What's the destination? 192.168.254.2. Who's that? That's the destination? Not necessarily. But it is destination when we leave, right? And then, I'm sorry. This is still the source. So this got translated to that, 254.2. And so it got translated to that. Let me erase this. All right, so this got translated to that. And then the destination is 254.1, which is who? That guy right there, right? And I believe, I don't know if that's a sequence number. I don't think that's a port number or anything like that. We got some expiring traffic because it timed out, right? Because it asked us to log in, and I didn't put no password there, and then boom, it expired. That's what that traffic right there is, right? Y'all see that? What else we got here? And then when we sent another ping, I believe it came back from 254.1. Who's that? That's this guy right here. Because remember, when you do a ping, it's basically like a radar, right? It's just going here, and it comes right back, right the hell back. That's basically what ping is, right? And then the destination was 254.2. Who is that? So it went from there to 254.2, which is that right there. Why didn't he put 10.224 if that's the destination? Why didn't he do that? Because he don't know it. That's what network address translation does. It masks the IP address. We're masking our private IP addresses. So all he know is that the destination is 254.2. That's all he know where it came from. He sent it out there, and then finally that address, once it came in, that was the destination. It got translated to 10.224. Who's that? That's this guy. So it came right back. You see that? I love this shit, man. This stuff is fun. The host makes up a port. On return, the packet uses the well-known port, e.g. port 23, to identify the traffic. Yep. That's what's up. Yes, exactly. Exactamundo. So that's pretty much it, man. If anybody wants to break that down, or if anybody knows what that is, I believe that's the sequence number. I don't think that's the port number, is it? 493 and all this other shit. Let me see. Let's do this. Let's look at the translations. Where's the translations at? Let's look at the translations. Show IP translations. Where we at here? Oh, none now. Statistics. We did the translations on here, right? What the hell is that? We got 100 hits and no translations? Is it because they're expiring? Oh, maybe that's why. So the NAT got expired. So it removed that. So TCP, that is, I believe that right there is the port number for sure. So I guess once it's in parentheses like that, that's the port number. Right? Because they don't show us the port number in here. Let's do that one more time. I'm going to send do we want to Telnet? Yeah, let's do a Telnet. Look at router 3. Boom. We got some right there. And now let's do a show statistics. No, translations. Boom. That got translated. Right? So what was the port number? The port number is 43873. 43873. So yeah, these must be like sequence numbers then. They not port numbers. So they just translated 10224, which is that guy right there. Right, that guy right there. And then he translated to 254.2, which is this right here. And then when it came out there, it went that way, which is 192, 168, 254.1, and then came back right back around, right? And all it did is just kept pinging, because you know normally by default when you send a ping, you send 5 pings, right? By default, you can change that. You can send 1,000 pings if you wanted to, but by default it does 5, and that's what happened there. So yeah, that's pretty much it, man. If y'all like what y'all see, y'all run me with that like button, man. Leave a comment down below or anything like that for anything else you want to see. Make sure y'all subscribe to this channel, because y'all know this channel's fire, man, and stuff like that, man. Y'all know how we do on this channel. We keep it funky. Next lab is going to be lab number 66, configuring pool-based port average translation. Damn, Pat. Just keep doing this, man. I might do, I don't know, if tomorrow I might, y'all done with the configuring IP addresses and VLANs and stuff? Y'all done with that? Because if so, then I'll jump straight to task 6, and y'all ain't got to worry about all that other stuff, man. Hopefully y'all know how to do that stuff, configuring VLANs and just the simple stuff. If not, then I'll keep doing that. But once we get the CCNP part or CCNP book of this version of this book, then we'll definitely pass the simple stuff, and that'll shorten these live streams to at least a half hour, because I've been doing this shit for like an hour, man. I should be out having a drink or something like that by now. But anyways, for now, comment, like, subscribe to the network.